So we put everything together in this chapter into this one problem called linear programming. Okay, now linear programming, it's not computer programming, although that would be pretty interesting. It's actually more just a math process. As with some of the things in this chapter, it might be something that you saw before. You might have seen something like this in algebra, or maybe you didn't. It doesn't really matter. Everybody can do it today. I'm just kind of warning you, though, it is a multi-step process. So it's not going to take just like 5 minutes. Sometimes till it's all said and done, it might take 15 minutes. Once you get good at it, it won't seem too bad. Listen, it's actually a pretty realistic process. It's not something where we just kind of do it in the classroom and then nobody ever does it in the real world. This actually is something that somebody actually does in the real world. Besides just teach math, again, people actually do this. What they do is basically analyze data for an optimal value. Okay, optimal values are typically what businesses try to find. That is, if they want to stay in business or make a good profit. I always tell the story that my wife's friend's husband, he actually does do this for a company in Allentown. He actually paid his way through college and said, as soon as you're done, this is your job. So I got talking to him one time. We do talk about other things like fishing and camping, but sometimes work comes up and I was like, oh my gosh, that's exactly what I'm teaching my students. And although he's doing it a little bit more in a complicated level, it's essentially the same thing that I'm doing with you. So what is this? What is this thing called linear programming? Well, it's going to be to try to find an x and a y. X and y is a point that maximizes or minimizes an objective quantity. Okay, so it's going to feel like all the stuff that we've done. We'll just show you how to put it all together. Okay, now on that slip of paper that you picked up, on the back side of it, you'll see the steps to this process. The reason I show that or say that is because I don't think you need to copy down the steps. Okay, most people don't feel like they have to copy down these steps. They're on the back of your little slip of paper, but I still kind of want to show them and I want to just speak about them quickly. Okay, we're going to come up with unknowns. That's like the old what's x equal, what's y equal. Okay, the unknowns. You're also going to write something called an objective quantity equation. That's going to also kind of feel like an unknown, but it's going to be an equation that uses x and y. Now, normally that's going to be profit. Okay, maybe you want to write the word profit on your little slip of paper. Again, the objective quantity is almost always going to be profit. Okay, you'll be able to do this. It's just a matter of kind of just focusing and realizing how to put all these steps together. The constraints, those are going to end up being a system of inequalities. Okay, you're going to end up writing those. Like, you're going to have to think about them. Students quickly realize that that's the hardest step in this process. Okay, the reason it's the hardest step is because everything in the rest of the problem is based off your constraints. The graph is based off your constraints. By the way, the graph is going to be a shaded region, hopefully kind of like what you just turned into me, with corner points. And you find out that those corner points then get plugged back into the objective quantity. And as I was saying a little bit in class the other day, the corner points are the most important points. Again, those end up being the ones that we use. Okay, we can obviously talk about this all day, or we can get into a problem, and that's what we're going to try to do. I encourage you to read that first example on the front. Honestly, you might want to read it twice, but read it. It's the telephone problem. Okay, it is an interesting problem when it boils down to it. Maybe it seems a little silly right now. Who in the world's going to have a telephone that only gets a $9 profit? I don't know. Maybe it's actually in hundreds. Maybe it's $900 profit. Okay, but we're going to keep it simple for the sake of the problem. But do you get an idea what's going on here? We're making two things. There's different requirements for making them. Those requirements end up being the constraints. We need to figure out how many phones we're supposed to make. It's not as easy as just saying, well, make as many as you can. There's only so many you can make because it says that the machines will only work for so long, which maybe would be like, the amount of people that you have working. Okay, but to go back to the beginning, it's to realize that there's two unknowns, which are the two types of phones. Now, it's not the color of the phone, it's not the cost of the phone, it's literally how many phones. It's the, hello, I'm going to pass today, but thank you. Okay, so it's the number of phones. So we'll say that X is the number of deluxe phones. We'll say that Y is the number of standard phones. By the way, you could have did this in the other order. It doesn't matter, but we'll do it this way this time. Listen, try to get your mind wrapped around right now that we're trying to figure out how many phones we're going to make. That's what X and Y represent. Now, the objective quantity is kind of like another unknown in this problem because the objective quantity is what I'm trying to optimize. It's the profit. Because really what this boils down to is then how much profit will I make if I make so many phones? Well, we don't know. We don't know, but we do know that it's an equation, or I should say we do know that you make $9 for every X phones, so we can write that as an equation. In a similar way, you make $6 for every Y phone. But again, I don't know. I don't know what profit I'm going to make because I don't know what X and Y are. Seems like a lot of things I don't know. Okay, this is like the main part. You're going to do great with steps 1 and 2. And I believe you're going to do great with step 3, but you're going to have to think to get step 3. And this is where you have to read and you have to interpret. And it's all in the middle of this paragraph where we talk about how many machines are available to do this and do that. Just kind of look in the middle of the paragraph again. It's always a little strange for me to start this, but I have to start it this way. There's 2 assumed constraints. The reason they're assumed is because there's nothing else said more powerful. Let me just say that both X and Y have to be greater than or equal to 0. Okay, now I don't like in math to do too many things where the teacher just says, hey kids, that's just assumed. But if you think about it, all this is really saying is I can't have any negative phones. Now somebody says, is it always X and Y greater than 0? Unless there's something more powerful said. Like maybe something more powerful says you got to make at least 10 deluxe phones. Listen, if you read that in a sentence, I got to make at least 10 phones because that's what the boss wants. Now X has to be greater than 10. But you didn't read that. Okay, so we don't have that constraint. It's almost like we go back to the default, greater than or equal to 0. Now, there's 2 other constraints, and they have to do with the machines. Again, it's a little hard to read, but if you look in there, you'll find out that to make a deluxe phone on machine A, there's 3 hours available. Okay, and it's right there in that next sentence. It says that each deluxe phone requires 3 hours of machine A. In the next sentence, it says that 1 hour, check that, 2 hours is what is required for every standard phone. Now, I had to move to the next sentence because 3 hours is machine A and 2 hours is machine A. And if you go to the next sentence, it says that there's only so many hours that machine A is available. So it's a little tricky, but if you see it after the teacher writes it, I hope you see that those 3 numbers are machine A. And sometimes we call this like the machine A constraint. What's machine A doing? I don't know. It's kind of, we're simplifying things, but maybe machine A is cutting out the phones or something. Okay, so machine A does its own thing. Can you write the other constraint? Can you write the machine B constraint? Can you take what I did for this one and kind of adapt it to be machine B? You have to grab the numbers out of 3 sentences. It takes an hour to do whatever has to be done for phone X. It still takes 2 hours to do whatever has to be done for a Y phone. And for some reason, that machine is only able to work for 8 hours. Whether you fully understand this or not, these statements up here, these constraints, this system of inequalities, represents all the possible solutions for this problem. In other words, it represents all the possible phones that I could make. Do you realize that that's what this problem is all about? It's all about trying to figure out how many phones I can make. So if I graph this, I'll be able to see all the possible phones I can make. Okay, so we get to everybody's favorite part, graphing. This is why we did the lesson on Friday. Graphing the first 2 constraints is pretty easy, done. It's basically quadrant 1. Now, this third constraint, let's try to make this easy, okay? Listen, don't solve this for y equals mx plus b, unless like you just, are sort of like, I'm going to solve this for y equals mx plus b. I'm not going to stop you, but I'm telling you, it's a lot easier to plug a 0 into that equation. Because if you plug a 0 into that equation, everybody can see that y should equal 6. That's the y-intercept. And you found it by just plugging a 0 in for x. And look, if you plug a 0 into this equation for y, it's kind of hard on my shoulder here, but if you plug a 0 in for y, you get x equals 4. Okay, it's 3x equaling 12, so x equals 4. And boom, you have yourself another point, and 2 points make a line, and that's really what we were trying to do. Now, really what we're trying to do is get a shaded region, right? We need a shaded region. So don't forget about shading based on the less than sign. But a little quick thinking about a test point, you should conclude that you're going to shade on the true side. You're going to shade on the true side. That's because when you plug in 0, 0, it comes out to be true. Now, I would encourage you to think about graphing the other constraint. And I would encourage you to think about doing it by plugging in some zeros. Okay, because, well, again, it's usually pretty easy to plug a 0 in for x and solve for y, and vice versa. Okay, you should have plugged a 0 in for x and got y equals 4. Plug a 0 in for y and get x equals 8. Please speak up if you have a question on what I did there, because I know I did most of that mentally. I don't want it to be a mystery how we're getting that line. I hope you're shading that line on the true side. The true side, as the test point of 0, 0 also comes out true. Okay, we end up with this little 4-sided region. That little 4-sided region is technically all the phone possibilities. And just, again, to be honest with you, right now, if I was the person in charge of this little analysis, I could say, hey, as long as you make a phone that's in this shaded region, we're fine. Like maybe make one of each phone. Now, if you make one of each phone, do you think you're going to get like the most profit? Probably not, because look, you can get a little bigger. I could make 4 of the standard phones. Or if I go out here, I could say, wait, I could just make 4 deluxe phones. Now you see what I'm doing here? I'm starting to get to the corner points. The corner points are like the extreme points. They're like the biggest numbers. Well, most likely the biggest numbers are going to be the ones that give me the biggest profit. So let's go search for the corner points. Now, technically, 0, 0 is a corner point. It's always kind of one of those technical things. But if I don't make any phones, I'm not going to make any profit. But I want to be technically correct, which means I'm going to put 0, 0 on the list. Now, please note that there are some points that don't make the list. Like, I can't make 8 phones. It's too much. If I make 8 phones, I'm going to overwork one of the machines. Okay, so it's only the points that are back in the shaded region. But your eyes should be kind of contacting this unknown point. And how do we find it? How do we find the intersection of 2 lines? That's been the whole premise of this chapter. The intersection of 2 lines is like solving a system. So back over here, we actually can take those 2 equations. I'm going to recopy them because I need some space. But I can take those 2 equations and I can solve them like a little system. Okay, and remember all the things that you've either learned or reviewed in this chapter. You can solve that system with matrices, although it's probably going to take more work to get your computer out than it would be just to throw a little opposite onto this and use a simple elimination method. But you can solve this any way you want. Keep in mind that when you solve it, you're actually finding the intersection point of these 2 lines. Okay, it looks like x is going to equal 2. And if you plug 2 back into one of the equations, you quickly see that y equals 3. Which really is like saying that I'm going to make a little bit of both phones. I'm going to make 2 of the X phone and 3 of the Y phone. Maybe that will be my best profit, making a little bit of both. So are you starting to get a sort of the big picture of this problem? What I've been speaking about, if I make so many phones, what I'm really speaking about is this profit equation. And this is the rest of step 5, which is you're going to plug back into the profit equation. Now, again, if you don't make any phones, you're not going to make any profit. But what if you make 0 deluxe phones, but 4 standard phones? You're going to make 0 profit on the deluxe, but you're going to make $6 for every Y phone. Obviously, that's $24. Again, maybe it's in hundreds. Maybe it's actually $2,400. What if you say, hey, we're just going to do all deluxe phones? Well, now you're going to make $9 for every one of those 4 phones. Again, it's pretty basic math. It's kind of meant to be that way. Well, that's better. Now I'm up to $36. And maybe you want to just spend a moment thinking about what happens if you use a little bit of both. Okay, so you get 18 plus 18, which is also 36. Now, if you're my wife's friend's husband, if you're that guy that does this, you walk into the boardroom and you say, hey, we can specialize in just deluxe phones, or we can make a little bit of both. But either way, we're going to end up with a $36 profit. And then somebody else has to make that decision on what they'll decide to do with their company. Okay, but what I want you to do is I want you to make that statement. I want you to say that you can have a maximum profit. Now, this is kind of like the final answer. It's a little statement that you're going to write. And you're simply interpreting what you just did. So maximum profit of 36. And then you can say with, and again, I can interpret my answer up here as 4 deluxe phones, 4 deluxe, but 0 standard. And since this problem is unique, it kind of has a tie. In other words, I can get the same thing accomplished with 2 deluxe. So I can say or 2 deluxe and 3 standard. But we make a little statement that kind of summarizes what we came up with. What do you think? Sign me up? Okay. People actually do this kind of stuff. Again, it would be on a more complicated level, meaning there's probably way more variables than just X and Y, but we could work with more variables. We have a matrix method. Okay, but we're going to stick with just 2 variables in the classroom so you guys can graph it and kind of make more sense of it in the time that we have. Now, normally what I ask kids to do, or at least I encourage you to do, is to try a problem. I know I just did one, but really it's your turn to try to work through, and that lumber problem is just perfect. It's a little different, but it's a little similar. The lumber problem. Again, it's a little bit different, but just similar enough that you can use what I showed you. Go ahead and read it, maybe read it twice. Now, I'm going to kind of be like a step behind you, and if you would like to be able to compare your work, I'm going to highly encourage you to let X be lumber and Y be plywood. If you did that the other way, just switch it, because if you're going to want to compare your work with mine, you're going to want X to be lumber and Y be plywood. Try to work through the next step. If you are stuck, I'm going to show you. Now, most of you have attempted step 2, which is why I'm going to show you the answer. If you haven't tried it yet, don't look. Although that's hard to do, right? Because you're going to look, but make sure your steps are correct as you go. And if you need to change it, here's step 2. Now, I told you the constraints can be tricky. For this problem, there are 3 constraints. I don't want to just show you those yet because this is the main part of the problem. If you want to talk to a neighbor and see how they match up, now, I'm impressed that most of you wrote that x has to be greater than 200. Did you hear me? You're correct. You said x has to be greater than 200. You also said y has to be greater than 300. That's really good. So we're gonna not use those assumed constraints because we can do better. We can say x has to be greater than 200, y is greater than 300. You're kind of normal. A lot of kids do this, but it's this third constraint that some of us are making too complicated. It seems like what more of you need to realize is that this constraint simply says that the total amount of x and y, that's all that is saying, the total amount of x and y can't exceed 800. I don't want to multiply something times x because, again, you're just simply saying that I want the total of x and y. If I can be of more assistance, just ask. Otherwise, I hope you're trying this. I'm trying to give you a chance to think about it before it's graded. You're trying to graph these 3 things. No, this isn't graded. I'm saying before something's graded. Maybe.
Okay. I was trying to get my notes.
No, you're good. I hate to see you sort of mess up the problem just because of these 2 horizontal and vertical lines. But be careful. Again, you guys are kind of normal, but it's these horizontal and vertical lines that sometimes throw us off. It's simply a horizontal line at 300, a vertical line at 200. And then there's also a diagonal line. A diagonal line give yourself a chance to think about it. And you guys, I like what you're doing. How does the diagonal line kind of interact with all of this? I hope that you're using intercepts of 800. 800. Okay, so we end up with, I have it up on the screen again, we end up with those 3 lines. Now remember, you have to think about the shaded region. Don't just assume that the shaded region is always the inside. Don't assume that. Make sure that you find it. Okay, because you would be shading in a manner that would put you on the inside, you could and can shade that triangle. Your diagonal line is going to put you down into that triangle. Are you still thinking about the problem? I hope you are, because you're actually to the most important step. It's funny, everything you did was to get you to the corner points. Do you feel like that you know how many corner points there are? How do you determine their value? If you think about it, this system doesn't require any real fancy solving. In fact, this corner point down here is just the intersection of my two consistent numbers, 200 and 300. So might as well mark that one off. That's 200 and 300. This corner point over here has something to do with the diagonal line. But if you think about it, this diagonal line is simply saying that I need to equal 800. Well, one of the numbers you already know. You already know that y equals 300. You already know that y equals 300. What's left to equal 800? See how I'm substituting, but it's a simple substitution. I'm substituting into my diagonal equation. Same thing up here. This corner point, I know that x was 200. That's consistent. X is 200. What's the rest of it have to equal so that, of course, it's equal to 800? Okay, so you have your three corner points. And again, the three corner points are those numbers in black. You're almost there. Now tonight, you'll have one problem to try. Make sure you remember tonight because there's one homework problem. That'll be a day to remember, one homework problem, but it's one of these. Tomorrow, you'll eventually get a little assignment where I ask you to do these problems for a grade. So again, before it's graded, do you feel like you know how to finish this problem? All you have to do is take those corner points and plug them in. It's probably going to require a calculator, but just out of time. But I plugged in 200 and 300. I plugged that in to my profit equation. Okay, so I obviously end up with 3 profits, but we're looking for the maximum profit. And you want to be able to make a little statement. When you make the statement, you want to say kind of the whole shebang. 200 units of lumber, 600 units of plywood. So I want to use some words. I want to use some labels. And that's going to get me a max profit of $22,000. If you're still engaged with me, you might say that you're not that surprised because, look, plywood gets you more money. Well, that's exactly what these answers show. I'm going to use the answer that uses more plywood. It looks like I'm going to use the minimum amount of lumber. That's why it's only 200 for lumber. But I'm going to use the most I can for plywood.